So here we have a vector valued function R with three components along the x, y, and z direction. Your t is a scalar parameter. I cap, j cap, and k cap are the unit vectors and they are constant. We need to show that the following differential equation holds true. So let us begin. So here we have the vector r, which is a function of the scalar parameter t. So that's given by sine omega t I cap. So this is our x component, plus cosine omega t, which is a y component, times j cap, plus t over omega squared multiplied to sine omega t. So this is the z component, k cap. Right. So we'll label this as equation number 1. Let's find out the first derivative of a vector valued function r with respect to the parameter t. That means we'll have to take the derivative of each terms with respect to t. Here we'll only take the derivative of sine omega t, although we have a product here, sine omega t times the unit vector I cap, because it's mentioned that I cap, j cap, and k cap are constant vectors, which means that if we take the derivative of a unit vector I cap with respect to t, so that will be equals to 0. This also holds true for the other two unit vectors. That means derivative of j cap with respect to t and derivative of k cap with respect to t, that will be equals to 0. So that means we can treat I cap, j cap, k cap as constant here. The derivative of the cosine function, that will be omega times cosine omega t. So here omega has come as a result of applying the chain rule, multiplied to I cap, plus derivative of the cosine function will be negative omega sine omega t j cap, plus, so here we have told that omega is a constant. So I've missed it out. So omega is a constant. That means we have t times sine omega t. So we'll take 1 over omega squared as the constant. So let's take the derivative of t times sine omega t using the product rule. So we have sine omega t plus omega t times cos omega t. So this is going to be our z component of the first derivative of r with respect to t. So let's call it equation number 2. We'll also need to find out the second derivative, because in our differential equation we have the second derivative of r with respect to parameter t. So let's find it out. So we have second derivative of our vector valued function r with respect to t. So this will be equals to, so we'll have to take the derivative of omega cos omega t. So that will be negative omega square times sine omega t. So this is r I cap, plus negative omega squared cosine omega t j cap, plus 1 over omega squared. So we'll take the derivative of each of the two terms. So derivative of sine omega t, so that's omega cosine omega t, and we'll have to use the product rule here. So this will become omega cosine omega t. We'll come to the sign in a moment. So we need to take omega t and then multiply it to the derivative of cosine omega t. So that will be sine omega t. So this will be negative, and we also have a factor omega. So this will be our unit vector k cap. So this is the z component. So we have omega cosine omega t and omega cosine omega t. So this will add to become 2 omega cosine omega t. And if we multiply it, so we have two terms within the parentheses, we multiply it with omega squared. So this will become 2 over omega, and this will simply become negative t sine omega t. So let's rewrite it to get, so we have negative omega squared sine omega t I cap minus omega squared cosine omega t j cap plus 2 over omega cosine omega t minus t sine omega t. So this is k cap, and this is also k cap. What we'll do, we'll consider the first term, second term, and the third term and take negative omega squared as the common factor. So we have negative omega squared, so that will be now multiplied to sine omega t I cap plus cosine omega t j cap plus t over omega squared times sine omega t k cap, and we leave the third term as it is. So that is 2 over omega cosine omega t k cap. Now, if we look at equation number 1, so this is our vector r. So we have considered our vector r to be this. That means we can replace this with negative omega squared times vector r plus 2 over omega times cosine of omega t k cap. So this is our second derivative of the vector valued function r with respect to t. Rearranging it, we should get now d squared r vector divided by dt squared plus omega squared r vector. So this is equals to 2 over omega cosine omega t k cap, and this proves our problem. So there's a typo in our problem, so I wrote here I cap instead of k cap. So this is actually the unit vector k